We want to show the relationship between the change in the entropy with respect to temperature and pressure, temperature and volume and pressure. Now we say that the change in the entropy is equal to the change in the change in the heat content all over temperature. And from our first of thermodynamics, we say that the Q equals to the U plus the W, where the Q equals to small change in the heat, the U equals to small change in the internal energy, and the W equals to small change in the work done. Now, if you divide Q out by temperature, you have the Q over T equals to the U over T plus the W over T. Remember, the Q over T is the same thing as what? The S. We have the S equals to the U over T plus the W over T. I said earlier that the U equals to mCV dt at any point. So now when we take our mass to be equals to 1 kg, we have the U equals to CV dt. Now the W here now, we say that W equals to pressure times change in the volume. W equals to pressure. W equals to pressure times change in the volume. PdV. Now remember that if you say that W equals to PdV, then we have P with respect to the change in the volume. Here we have P over T. Back to our ideal gas equation, PV equals to mRT. We can make P and T solve the formula. P over T solve the formula to have R over V. Now after getting your R over V, substitute your P over T to be equals to what? R over V. Now, the main reason why we are substituting them is that we want to integrate this function with respect to the change. The change we have here is with the volume. The one we have here is the temperature. That's why we have to change from pressure over temperature to gas constant, no matter gas constant, all over volume. CV dt over T plus R over V dt now. At this point, we have to integrate the function from the first point from the initial to the final. At the first point where you have your entropy as S1 to the S2, you are taking it from T1 to T2, you are taking it from V1 to V2. Now, if you integrate this function, you have S2 minus S1. If you integrate this one, you have CV in T2 minus T1 because CV is a constant, 1 over T, you get the length, and then you have your T. But here now remember that if you are working with length, T2, you don't say min T2 minus min T1, you say min T2 over T1 plus. Here also you have your R as a constant. You have ln V2 over V1. You don't say ln V2 minus 1, you say ln V2 over V1. Now this is the first thing we proved, which shows the relationship between the temperature and the volume. But we are not done. We want to use this one also to prove the subsequent one. Yes, and now we have is T1 V1 over T1. From this our general equation, we can now make T2 T1 T2 over T1 the subject of the formula. P over T1 equals to P2 over P1 times P2 over V1. Remember, from this equation we have T2 over T1. I want to move this T2 over T1. I want to put P2 over P1 times V2 over V1. P2 over P1 times V2 over V1 plus R in V2 over V1. Now, I can expand this bracket to give me this, and I can expand this one to give me this. CV in P2 over P1 plus CV in V2 over V1 plus R in V2 over V1. Notice that this value and this value are the same, right? So if they are the same, we say that if you take the like terms, in V2 and in V2, you have them here. Then CV plus R is equals to CP. So your final answer is CV in V2 over T1 over P1 plus CP in V2 over V1. Now we prove this one in terms of pressure and volume. Now the last one is to prove them in terms of temperature and volume now. Temperature and pressure. Now to make this temperature and pressure, we need to make V, which is the volume, the subject of the formula now. Subject of the formula V now will be equals to V2 over P1 will be equals to pressure P1 times T2 all over P2 times T1. If you expand them, if you separate them, you have P1 over P2 times T2 over T1. You can now come back to this equation. Your P2 over P1, rearrange it. This is P2 over P1. In that equation, I've already turned it to, V2 over P1 in that equation, I've already turned it to P1 over P2 times T2 over T1. Expand the bracket, CP in P1 over P2 plus CP in T2 over T1. Now from here now, you can now find CP in P2 over P1 and CP in P2 over P1 over P2 over P1. I said that we want to rearrange the equation so that it's going to have the same thing. I said if you have the lean now, what you do is that P1 over P2 will be equals to, when you sweep it, you have P2 over P1 and then this value turns to negative. Then if it turns to negative, you have Cv in P2 over P1 minus Cp in P2 over P1. From here now, Cv minus Cp is what you have to look for. Remember that we say that Cp is equals to Cv plus R. Now listen. If you have Cp equals to Cv plus R, I can say that if you bring your R to this side, you have minus R equals to Cp equals to Cv. If you bring Cp to the other side, you have minus R equals to Cv minus Cp. So now you see minus R equals to Cp minus Cv now. I can remove Cv minus Cp and turn it to minus R. Minus R in P2 over P1 plus Cp in P2 over C1.
I do this every
If I arrange the equation, I will have S2 minus S1 in terms of Cp in P2 minus C1, all of minus R in P2 over P1. Ladies and gentlemen, we call it a day.